Yeah, good evening, friends. Welcome to the Domain Analytics program. And we were uh, seeing legal and law analytics. So today we'll be seeing some of the applications in classification of legal analytics. Okay. So let us see. So today we'll be discussing about KNN classifier. So let us first know what is KNN classifier. KNN, the full form of KNN is K nearest neighbor. Okay, and it is a simple supervised learning algorithm, a supervised machine learning algorithm, we can say, and it operates on the basis of similarity between data points or similarity between cases. Okay, and we need to find it, the similarity of a data point with nearby points from which it is most similar. So we have to measure this similarity between all the points, and based on this, we will classify this point to a category. Okay. Now this algorithm KNN can also be used for regression problems. It can also be used for regression, but today we'll be discussing about classification only. So let's see. So let us start with some of the properties first. KNN is a non-parametric algorithm. It is a non-parametric algorithm, and it means that it doesn't make any assumptions on the data. Okay. Non-parametric meaning doesn't make any assumptions. On the data. KNN is also known as a lazy learner program. Or a lazy learner algorithm. Why? It is known as a lazy learning algorithm because it doesn't learn from the training set immediately. Okay. Instead, it stores all the data first, then at the time of classification, it performs its action. Okay. Basically, what happens is KNN at training phase just stores the data set. Okay, training phase, it is just storing the database. It doesn't database, it doesn't do anything at that time. Whenever it gets a new data point, whenever it is getting a new data point, it tries to classify the data into the categories. Different categories we are having in this database. Accordingly, it will try to classify it when we are getting a new data. tries to classify them, classify the data into a category. So which category? Again, so to decide this category, it looks for nearest neighbors. Meaning the points which are most similar to the new data which we are storing, okay, which we are giving it. The data points which are most similar to this will be chosen. Okay, so let's see. We are having something to deal with also k value. So let us learn what we can do for different k values. What changes will happen? Let us learn about that also. So today's agenda will be learning nearest neighbor. What is a nearest neighbor classifier? Then we'll learn how to select the k value. Then we'll learn what is one nearest neighbor classifier, what is k nearest neighbor classifier. Then we'll also learn about controlling complexity, how to control complexity in KNN. Next, we'll be learning about Euclidean distance. What is a Euclidean distance? Next, advantages and disadvantages of KNN. Next, some use cases in our domain analytics, that is legal and law. So, suppose this is what our database, this is our database which is stored at the training phase. So this is just stored at the training phase. Then when this new point comes, okay, we will see which is the nearest neighbor to this point. Okay, then we'll measure from all the points the distance of this point. Okay, so from this point to this to this again, this to this, all the points will measure the distance, and whichever point is most similar to this will have the smallest distance. So whatever category this point falls in, will also categorize this data in the same category. This is the underlying idea of KNN. So let's see. So this is how it happens. So we are having this gray point, okay, and we are having three categories: yellow, green, and orange. So we'll calculate the distance. So you can see it is 2.1, 2.4, 3.1, 4.5. Okay, we are having different distances. So we are trying to classify where this gray dot will fall from all these distances, or all these points, in which category it will fall in. So we see distance from both of these yellow 2.1, 2.4. And from green it is 3.1. These are the nearest ones. We are just measuring all the nearest ones. And fourth nearest neighbor is 4.5. So here we are measuring with k value equals to 4. So we are taking 4 nearest neighbors. Okay. Then on the basis of votes, we will decide. So whichever has the majority, whichever category will have the majority, we will decide that as our category. So from voting, we see this yellow is having 2 votes, others are having 1 vote. So we will decide this yellow one as our category. Okay, so this is how our k means is working. So sorry, k nearest neighbor is working. Also, I'll just underline all the steps here so that it will be easier for you. So KNN, how it is working, we are seeing here. So first we'll select the number of k, how many neighbors we want it to be calculated from. The distance from how many neighbors we want to calculate, that will give first. Then we'll calculate the Euclidean distance from k number of neighbors, k number of closest neighbors. We will calculate the Euclidean distances. Okay. Then we have calculated the Euclidean distance from k nearest neighbor. Among this, we will count the number of data points in each category. Okay. So from this, suppose I have taken k value as 5. Okay. So suppose there are 3 categories. So I'll measure which category is having. So out of these 5 points, suppose this is 0 category, this is 1, this is 2, this is again 1, and this is again 1. Suppose I'm having something like this. Okay. So when I look at this, I see that the 1 category is having the highest vote. So I'll say that this point is closest to the 1 category. So we'll take this category as the category of this new data point. So this will also be belonging to 1 category, or category 1, we can say this category. Okay. Once this is done, our model is ready. Now, how to select the k value? How can we select the k value? So, few things you should remember while selecting the k value. If we select k equals to 1, okay, the classes are divided into regions and the query record belongs to a class according to the region it lies. So, if k we are selecting 1, so these will be separated into 2 regions, and in whichever region this point lies in, we'll say that is its category. Okay, or we can say the nearest point, whichever region it is lying or whichever category it belongs to, we will choose that. And if we are having also, you should remember, if we are having 2 class problem, if we are having 2 classes or 2 class problem, okay, or 2 category if we are having, so always choose odd number of values as k. Okay, and also k should not be a multiple of a number of classes. If we are choosing a k value and we are having a category 3, so this k should not be a multiple of 3. Okay. So these are some of the criteria you should remember before selecting a value of k. Next, suppose we are having this scatter plot. Okay. This is y-axis and this is x-axis. Okay, this is our scatter plot. So suppose this is the new data which we want to classify. Okay, so first we are taking k is equals to 1. So as we are taking k equals to 1, we see this belongs, this is the closest one. So we'll say it belongs to the pink. Okay, pink and blue, we are having 2 categories. So we'll say it belongs to pink. Next, we saw when we are taking 2 category or 2k, value of k is 2. We are taking value of k as 2. Now we see that we are having 2 nearest neighbor and both are of different categories. So how to choose now? So that is why we say that k, when we are having a binary class, should not be a multiple of 2, or this will cause disambiguation. Okay. We'll be confused because if we are taking voting, we see both are having equal votes. So we cannot know. So here what we can do, we can choose from Euclidean distance. Whichever is closest, we'll choose that. Okay. Once, let's see if by increasing our value of k. So as we increase our value of k to 3, we see that now it is blue. Okay, 2 blue. So votes are more for blue. So we say it belongs to the blue category. Okay, now I am taking a very large, you can say 8 nearest neighbor. I am looking for this. So we see we are having pink 5 and blues are only 3. So we'll say this belongs to the pink category. Okay, so this is how we select the k value and the category. So category will depend on the k values. Okay, now this complexity. So let's learn about complexity. So suppose this is the k value. Okay, different k value we are having here. And here we are having different value of accuracy. Okay. So if we see a certain value up to a certain value of k, we see that the model trains well. But after this value, okay, we say training is good. But on the test set or validation set, the accuracy will start, decreasing and we cannot do anything. So this is the limit up to which we can take the value of k. Okay. After this value, our model will not be accurate. Okay. It will not show good result. So always we have to take up to this k value, any k value we can take. Okay. So a very large k value will not give us a good result. Okay. So if we are taking a very large k value, what is the problem here? See, if we are getting a good training accuracy, but validation accuracy is not good. What condition is this? This is overfitting problem. Okay. So when we are doing this accuracy testing, if we are having a train accuracy good, but test accuracy is not that good, we get an overfitting problem. Okay. So this is to be avoided. So we should choose a k value up to this limit. Okay. It is the right level. At this point is known as the right level of model complexity. Okay. Beyond this, our data becomes very complex. This model becomes very complex and it is very hard to control it. So up to this k value will be taken. Okay, now let us see a sample data. So suppose I am having few of the ingredients like apple, grape, orange, green bean, cucumber, nuts, and many more we are having. Okay. And this is, we are basing this data on the basis of sweetness and crunchiness. Okay, sweetness and crunchiness, and our Y or the category is what is the food type. Okay, so fruit, vegetable, protein. Okay, different categories we are having. Okay, so sweetness 10, 9, 11, 4, crunchiness. Okay, accordingly we have arranged this. Okay, so I'll just this data I'll just show you in a scatter plot. Okay, this is the scatter plot. So you can see the scatter plot. So just by looking at this, can we make some inference? Can we say that something is related to something or something like that? Okay. Can we, are we having any linear relationship here? Okay. Are we having any linear relationship? So we see we are not having any linear relationship. We cannot detect any linear relationship. But one thing we can detect here. So if you see closely, you can see that these are all vegetables. These are all sources of protein, and these are all fruits. Okay. So this is based on how sweet it tastes and how crunchy it is. So this is a, we can say a category. We can also say this is a category, and this is also a category. Okay, so we are having three categories here. These are all vegetables. These are all fruits. And these are all proteins. Okay, so we can see how sweet it tastes. So these proteins, they are not that sweet. So these are like this. So cheese is the lowest because it is a bit salty, we can say. Nuts, they are a bit of having more sweetness of all this. Fruits obviously are having more sweetness, so they are at this end. Okay, and how crunchy it is if we see. These are crunchiest. Okay, in fruits if we see, apple is the crunchiest, pear, then grape, orange, banana is the least crunchy. So these kind of data we are having. So let's see what we can do with this. So I have just clustered it. You can say this is some kind of clustering only. We are doing this. Okay, categorizing them into different, clusters. So these are all vegetables, these are all fruits, these are all proteins as we as we saw earlier. Suppose we have a new data point. Okay, our new data point is tomato. Tomato, whatever we call this. We are having this. So we are trying to find where does it belong. Okay, so we'll measure the distance. Suppose I'm taking k value equals to 4. I'll measure the distance. So the closest one we are having green bean, we are having nuts, we are having grape, we are having orange. So where does this belong? We now want to find this out. So just a second. So for that, we'll just build a, this Excel sheet. So let me share that. Okay, so this is the same thing. So apple we are having, grape we are having, orange, green bean, cucumber, and nuts. Okay, and these are the various values we are having for that. And tomato is having these values. So we are trying to find what is the category of tomato. Okay, and by the Euclidean formula, we have found these values. Okay, so if we are taking k value as 1, so we are trying to find which is the nearest one. So we can say grape is the nearest one. If we are taking it k equals to 1, so it falls under fruit. If we take k value 2, suppose k is equals to 2. K is equals to 2, we see which is the nearest one from these two. We are having either fruit or protein. So we see that the distance is still for fruit is less. So we'll take fruit 5. Fruit. K equals to 3. Okay. So the third closest value is this. Okay, still we are not having any majority voting. This is now a vegetable. So still from Euclidean distance, we can say it is a fruit. Then suppose we are taking k equals to 4. Okay, so this is the closest. So we are getting a clear winner. From voting, we can say it is a fruit. Okay, so like this we can decide. This is just an example. Okay, like this we will be able to decide. Based on these properties, these two properties, we are getting this value. So this is how we'll decide for different values of k. Where does this tomato belong to? Okay, according to our calculations, this is where it belongs. Okay, now this distance, how did we calculate? It is nothing but root over of. So suppose 6.4, it is root over of this 6 minus, suppose let's take grape. This 5, how did you calculate? Let's say it is a whole number, so it will be easier to calculate here. 6 minus 11 or 11 minus 6, whatever you can write, whole square plus 4 minus 4 whole square, which is nothing but the Euclidean distance. Okay, so we can see this is 0 and this is 5 square root over, which is nothing but 5. Okay, so like this, we are calculating each and every distance. Okay, so if we just click on this, you can see the formula. Square root of C4. So I have clicked on this thing. So C4, square root of C4 minus C10 and square root plus D4 minus D10 whole square. Okay. So this is how we are doing. This is nothing but Euclidean distance. Okay. So this is how we are calculating, and we'll say that this belongs to this group according to our calculation. Okay. Now how we are measuring the similarity? So locating the tomato's nearest neighbor requires distance function or a formula that measures similarity between the two instances. So here we will be using Euclidean distance. So there are many ways to calculate, but we are using Euclidean, and which is the distance one would measure if it were possible to use a ruler to connect between 2 points. Okay, shortest distance we will be measuring between the 2 points. Okay, so you can see in this figure, we are taking the straight line distance, shortest distance we are taking from tomato to grape, tomato to orange, tomato to nuts, tomato to green bean, tomato to cucumber. Okay, the shortest distances we are taking. Now the distance formula is nothing but if we are measuring a distance between P and Q, which are characterized by P is characterized by P1, comma P2, comma P3 coordinates, and Q is characterized by Q1, Q2, and Q3 up to N. Qn coordinates. Okay, this also up to N. Okay, so we can say the Euclidean distance is nothing but, let me write here Euclidean distance is equals to root over of P1 minus Q1 whole square plus P2 minus Q2 whole square plus last Pn minus Qn whole square. Okay, so this is how we find, and here P and Q are two records. Okay, P and Q are two records having n features, n variables. Okay, P1 refers to the value of the first feature of P, and Q1 refers to the value of first feature. These are all first features. So if I draw a data frame, okay, so these will be P values, Q value like this, and this will be P1, sorry, 1, 2, 3, 4 up to N. Okay, this value will be P1, this value will be Q1, this value will be P2, this value will be Q2, like this. Last value Pn, this will be Qn. So this is what the data frame is from which we are calculating this Euclidean distance between these two records. Okay, so here we try to find which class tomato belongs to given the values. Okay, and the values for tomato is the 6 sweetness and crunchiness is 4. We found that using Euclidean distance. Suppose from apple, let us take apple. Apple is having a score of 10 and 9. Okay, these two values apple is having. So let's see. Okay, 6, 4, 10 and 9. So if we want to find the distance, we'll say 10 in minus 6 whole square plus 9 minus 4 whole square. So this will be 4 square plus 5 square root 16 plus 25 root or 1 4 root. Okay, so whatever value we are getting, we'll say that is the value. Okay, now let us discuss what are some of the advantages and disadvantages of KNN, of using KNN. What are some of the advantages and some disadvantages? So some advantages of KNN, if we see, it doesn't have a training phase. So nothing happens in a training phase. We just load the data set. That is all. Now, complex models can be easily learned. Okay. And also it is very robust to noisy data. It is not that much affected by noisy data. Okay. So now let us, these are some of the advantages we are having for KNN. What are the disadvantages? Let us learn. So for determining the value of K will be very difficult. Okay. Because different K value will give us different result. So we don't know actually which K value will be the correct value. Okay. So this will have to test and see. Okay, different results we'll see, and accordingly we'll have to use these results to find an inference. So it is actually very hard if we are getting different values for different values of K. It will be very hard to make sense of that kind of data. Now, it is very hard to apply on a high dimensional data. If we are having more number of columns, it will be very hard to apply. Not just columns, rows also. If we are having more number of rows also, it will be very hard. Again, computational cost is very high because here we are measuring a point's distance with different distance values for different points. So computational cost will be high. Okay. So if suppose we are having means a query which goes through all the records through this much time. Okay. So it will require suppose n time. It will take if we are doing for K records, it will take us log of K to the power n times. This much time it will take us. Okay. So it is very heavy computationally if you see. Okay. Time taken will also be greater for high dimensional data. Okay. So before going to this, okay, let's now discuss some of the use cases in legal analytics. For legal cases, how can we use this? Just a second. Okay. For legal cases, we can use this for information retrieval. Okay. So what is information retrieval? So it is nothing but a software program which is used to find material. Okay. Usually in documents of a unstructured nature, means like text data if you're having. So we'll use this information retrieval software, okay, to find materials, documents which are unstructured in nature. that gives us our information that we need. And we find this out from a large collection of documents or large collection of data, which is usually stored in computer. In computer, they are stored as text files. Okay, text documents or PDFs. Okay, in this form, if you are having the data, so we'll try to find information from this large collection of data using this information retrieval software. Now, what is the use of this? So it helps user to find the required information. So whichever information you require, it will help you find that. Okay, but it doesn't explicitly return the answer to their question. Okay, it will not give you direct answer to questions. Instead, it will give you associated files. It gives information about the existence and location of the documents that contain the required information. Okay, it will give you location of the file where we are having this information. So let's see how information retrieval system works. So we are having a large collection of documents. First of all, this large collection of documents, again, it is present in the computer as unstructured or text files. Okay, we are having an indexer which will index all the documents. Okay, this may be using NLP, natural language processing, to do this task. Once this is done, okay, then we'll ask, so we'll take the input from user. So user will input what information it needs. It will give its query, what information it needs, okay, in form of a query. And we'll just forward this query to the information retrieval system. Now this information retrieval system has already gotten the database, okay, text documents. The database it has already got, and we are also getting the query from the user. Now we will do some algorithm here. Basically here is where we do the KNN classification of these documents, and we'll match this new data. So this document is being stored here, and this is the new data like we saw in KNN. This is like the new data which we are searching, in which class it belongs to. Okay, so here we are doing that, and according to the information received, we will rank the different documents. Okay, how close is it to this query? We'll rank different documents according to the similarity index between the query and this document. Okay, once we find this, this is our result. We will give this result out to the user. Suppose the user is not satisfied with this result. Okay, if he is not satisfied, he can do query refinement. Okay, he can change his query, or refine his query, change some keywords. Okay, and once this is done, again this will be sent as a query, and again matched with different categories, and accordingly we'll again get the ranked documents as a result, and this will be again passed down to the user to check. Okay, so this is how our information retrieval system works. Okay, so this is one of the use cases of KNN in our legal systems. So let's see the next one. Classification of legal documents. Okay, so let us see the underlying steps, what we need to do here. Okay, so first of all, we will be having some training documents. or unclassified documents. Okay, we will be taking this and giving this as an input to our system. Okay, the first process in here will be data pre-processing. So whatever pre-processing techniques we saw earlier, all those pre-processing techniques will be done. Basically, NLP tasks like we saw tokenization, normalization, lemmatization, stopword removal. Okay, all this NLP tasks will be done. Then we will form this DTM, document term matrix. Okay, this will be the output here. Once this is done, okay, we'll next move on to the feature engineering here. Out of all the features, we'll select few features which we require. Feature selection will be done. Then we'll also do dictionary construction. Okay, based on this only we will be retrieving or not retrieving. We are classifying. So for this, we are creating this dictionary, and then we are also doing feature engineering. Okay, if our document is in correct form, we do not require this step. We will just, after stopword removal also, we can follow up with this step, feature weighing. Okay, so here each feature will be given a weight. Okay, based on based on category. Okay, then here we'll be having KNN classifier, and this will categorize the items based on whatever training document we have given. Based on that, it will classify the items. It will categorize the items. Okay. So what is classification of legal documents? Classification of legal documents will classify each of the legal documents to different categories. Okay, according to categories where it belongs, we'll just, you can say this is a categorization process. Okay, so why is it required? So we see classification of legal documents is a requirement because of a huge increment in legal cases. Now judgments are very complex. Okay, judgments are, so the documents, in these documents we are having judgments, they are very complex documents. Okay, and this might even span over several pages, and they contain a variety of information about a case. Okay, so what we can do, we can use our KNN classifier. So it will give us, okay, the approach. What is the approach we are following to classify? So we will split the documents into equal sized segments. Okay, we are having different documents. We will split them into segments according to this. So you can see these are different segments we are having. Okay, then we'll do selection of predicted category through plurality voting procedure. So we are having a plurality voting procedure. This is also similar to majority voting. Okay, so we'll see where this category lies. So basically where this document or the segment category lies, and we'll just put that in that uh, category. Okay, so these, suppose these are different categories. We'll put it wherever we find it nearer. Once this is done, then we can also measure the, or we can evaluate. Just a second. Yeah, so let us see the evaluation metric which we did in this use case. Okay, so here we are measuring precision and recall. So let us first know what is precision, what is recall. Okay, so precision, if we say, it is the fraction of correctly identified instance, correctly identified instance by total number of documents. Recall, on the other hand, is fraction of relevant documents. Fraction of relevant documents by total documents. Okay, so from our instances, we can see this is the precision. Okay, so this is the precision for segmented. So we can see segmented documents are having more precision than the whole documents. Similarly, this is the recall. So recall, we cannot, say, because somewhere it is more than the whole document and somewhere it is less. So we cannot predict it whole. Now let us see the accuracy. So this is also an evaluation metric. So we can accuracy with segment size, we are seeing different segment size. So a segment size of around 50, we can see. Okay, this is the accuracy measure. Sorry, I'm just saying the opposite. A segment size of 50. This is 50. These are segments. This is accuracy. A segment size of 50 gives us the worst result. Okay, around 54 something % of accuracy it is giving us. But an accuracy segment size of 100, it is giving us the best results. More than 80, around 84% we are getting it. Okay, but then as we go on increasing the segment size, okay, we are getting less. So we can take the segment size 100 as our segmentation criteria. Okay, so we can choose this. Okay, so let us see the coding part now. So here we are dealing with crimes in the year 2001 to 2017. 2001 to 2017 in Chicago. Okay, so I'm just loading all the required libraries here. And I'm also importing all the data sets 2001 to 2004, 2005 to 2008, 2008 to 2011, then 12 to 17. All the data sets I'm loading. So this is a snippet of the data set I'm having. So you can see we are having something unnamed, ID, case number, date, block, which block. You see a primary type, which type of crime it is, description, what is the description of the crime, what type of location it is, arrest or not. Okay, different values we are having. Okay, total number of columns we are having is 23 variables we are having in this. So we are dropping some of the values which we don't need, irrelevant ones. Okay, NA values also we are dropping, and also duplicates we are dropping, and we are just changing the or formatting the different columns to the correct format here. Okay, this here we are just formatting it to correct format. After formatting, we are just deleting the unformatted columns. Okay, then from that we are taking sample size of 1 lakh. Okay, and I'm calculating on this all the crimes, different crimes. So let us go to the EDA part. So here we can see the amount of crimes which we are having. Theft is the most crime, then battery, criminal damage, narcotics, other offenses, assault, burglary. Okay, so if we see by the amount of crimes, so this was by primary type, this is just amount of crimes. So major crimes, I think. So same, only here we are seeing more closely. Okay. Next, we are just applying. So we can say this is the heat map. So we are having so many columns. So heat map, we are just looking for correlation between the variables. Okay, whether it is correlated with the output or not, we are just checking that. Okay, next we are just doing the KNN classification. So let's see the evaluation matrix. Okay, here I am taking n neighbors is 150. 150 records will be checked, and it will be a weighted average. Okay. So from that we found here, if we can see, accuracy is not that good. We are getting around 34%. Recall also not good, 34%. Okay, precision also not that good. So basically we are not getting that much good result from our KNN classifier. So if from classification we are not getting good results, what we can do? We can change the classification algorithm or classify. Basically this KNN here is not giving us good result. So we'll be trying to change our classifier to some other classifier. Okay. So this other classifier will be seeing in the next session. What other classifier we can use so that our results will be better. Okay. So we'll be using other classification algorithm on this data. We'll try to get better results. So yeah, friends, we'll be In the next session, again, we'll be looking at different classification method, and we'll be trying to better it than this result. So friends, that was it for our session. Thank you everyone and have a great day.